Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
Hey, Kirk. I got an email this morning from ResearchGate. Are you familiar with ResearchGate?
Yes, I'm listed on there, and my books, and actually one paper you can download for free is accessible there. It was not published in a formal journal or anywhere else.
Oh, okay. But do you get requests every day for your book? Can you send me a free copy of the book?
Yes, exactly.
Yeah. That's sorry, I don't have the copyright for that. I can't send it to you.
Exactly. But if you look in the internet and Google it, you probably find a PDF copy somewhere.
Oh yeah.
Unfortunately.
But if you really want, so one of the thoughts on ResearchGate is every now and then they say, hey, somebody read your paper or somebody did a citation of it.
Yeah, I love those.
And so one of my projects here at the start of the year had nothing to do with a resolution or anything else. It was mostly something that distracted me from sitting down and writing another paper. But I went through my filing cabinet and I found a whole drawer full of technical papers from spanning probably 30 years of me, going to the library and getting papers, getting copies of papers. And I remember the corporate libraries where I used to work would send me a photocopy of the table of contents for us. I'd select a handful, or not a handful. I had dozens and dozens of journals that they'd send me the table of contents, and I would highlight the ones I wanted a copy of, and they'd copy it, photocopy it, and send it back to me.
Okay.
This is before, when I started doing that, it was before email. And it was a very convenient way to not have to subscribe to a whole pile of journals when you only want maybe one out of every other issue of it,
right.
One article of it. So it was a great way to just stay abreast of stuff and what people are talking about and learn something. But more often than not, I would be faced with a problem or a challenge or a technical issue I was trying to solve. Like years and years ago, I was trying to figure out exactly how do ceramic capacitors crack and what happens when that what happens when it cracks. Because they all don't just go open. Sometimes they don't. And so I was trying to find what was known about that. And I'd go to the library or call them and say, here's some searches. But that filled my cabinet. And so I'm going through all that stuff. And I found my original draft and the final preprint for my first technical paper, which brought up ResearchGate. And that's the one that I got a notice saying, hey, somebody just cited this paper. And I'm like,
yeah.
Wow, that was, almost 30 years ago. And I was like, and I'm looking through this stack of papers and I'm pulling out stuff that were published in the 50s that I, dug up and found those copies and printed them because they were core to some project I was doing or paper I was writing or whatever. Is it a Newton, Sir Isaac Newton quote? The only reason I've done what I've done is standing on the shoulder of giants. Was that? I'm sure I'm getting that quote wrong.
You're standing on the shoulder of giants, and that's, building. It's only because of the previous work of other people that you were able to, go this direct, move the science a little farther.
Right.
Right.
And you've talked about, you've learned so much from Dr. Hobbs.
Right.
And then you came out with your own book, which was, full of practical advice of how to do it. And
that's something that I don't think Greg emphasized so much in his book or was familiar with, because he was really selling the idea of going to limits and the idea of applying stress to limits. And that was, pretty radical for his time.
Yeah.
In fact. So he focused really on that because it was still pretty much selling it. By the time I started the book in 2011, Halt and Hass were well-established terms.
Yep.
So I knew that one of the things that hadn't been addressed was the ability of thermal stressing and thermal halt to skew the timings and signal integrity potentially in circuit boards and electronic circuits, which could identify a lot of what do you call it? Timing
issues in software. Yeah, I mean, and for an example, for folks that aren't familiar with it, is let's say you have a CPU that's going to open a valve, right? But it has a sensor that says, "Oh, there needs to be fluid on this side of the valve before I open that," kind of thing,
right?
Or certain pressure or whatever. And so it says, "Hey, what's the pressure?" And if it doesn't get an answer in so many milliseconds or so many cycles of the CPU, it says, "Well, it's not there. I'll make a safe assumption."
Right.
And if that signal is just delayed because of the copper is changing its conductivity, then it can miss that.
Right. The fact that conductivity and the impedance can be shifted slightly and cause the timing variation or show what will happen with some timing variation, especially when you have high thermal gradients, like a rapid thermal change in a circuit board. You kind of skew the different circuit elements in differential ways. Some getting hotter faster, some staying cool. And in fact, this is a nice or a potential tool that you could use. And one of the things is by rapid thermal transitions, you can differentially skew the different elements. And in the larger population, when you talk about lot-to-lot variation or within a lot's variation, that again, all timings are not going to be the same in every chip. I mean, there's variation in everything, and certainly in the speed. And in fact, Intel and AMD and other processor manufacturers have to measure the capability of the actual chip on the wafer to sort out and bend certain CPUs and certain components, like that. So we know that occurs. We know that variation will occur in the manufacturing, and by thermally skewing these, along with changing the bus frequencies and other variables, voltage, you can really map out a very, I think, in-dimensional safe area to stress under and to expect every product, every one of your samples to operate under. Yeah. And in fact, finding that boundary and finding out how wide those boundaries are is essential to kind of realizing you've got the design well centered.
Well, just that story, I mean, it was a reference to what you picked up and expanded on from Dr. Hubbs as just one example of how we learn from the past. But when you started talking about, the variability of silicon chips, just think of how many people and how many papers have gone back 70 years now, 60 years since the very first devices were invented way back when. And it continues I heard it just the other day that IBM lost its number one position for the most patent applications in a year or something like that. I think the Samsung. They're number two, but they're trying harder. But the idea is that there's so much wealth out there of knowledge. And for me, I mean, it was before blogs and online searches and all the other stuff that's out there. But the technical papers and journals and conferences to some degree, there's some variability there, are pretty well vetted. I mean, people do review it and look at it going, is this true, or does it make any sense, or can we, does this hold any water kind of thing? And it varies. Different journals have different levels of standards and review policies, but by and large, it's different than a blog where Like I just posted one today, and my review was I ran it through Grammarly to make sure I spelled everything right. You know, but you know that when you look at a blog online, it's that old saying is, do you believe everything you see on the internet? You know, like kind of
Yeah,
thing.
that's true.
You know, and I with Ascendo and with our podcasts, we try to give out, you know, or relate our experiences and history and all the other stuff in a just a different format. We could put this stuff all in technical papers and go through the publishing process. And we have. I know you've published and I have, and we've gotten conference papers published and stuff. But it's one of those things that I think has one, it's a record or a history, along with books and along with other vehicles that we use to convey and share information. So that's part of the scientific process, I think, and just our engineering development and technology innovations, all that stuff is founded on or this idea that goes way back to the Royal Societies and Sir Isaac Newton is, hey, what are you working on? Let's talk about it. You know, kind of thing.
Yeah.
What did you figure out today?
Right.
You know?
So yeah, I look at, when I see a citation, I sometimes go back referring to my book or one of my papers, but mostly my book. I kind of see it's interesting to go back and see what they use that for.
Yeah.
You ever look at that
Oh,
and
yeah.
see
Okay.
if they used it properly, to support something that you either agreed with and it thought it furthered the technology, or I thought, ooh, that's kind of misleading, from what I intended.
Yeah, the ones that I was like, oh, you're just filling space here. Is the academic
Yeah,
papers that,
yeah,
the thesis, the PhD thesis paper that, they have to do the literature search. So anything that
Right.
hit the keywords they list. So their
Right.
bibliography is 300 papers, but they only actually use the information from like 2 of them. That one's,
my
whatever.
friend or my colleague or one guy that I also consider very intelligent and the leader in academics of reliability academics, and that is Michael Peck, Professor Michael Peck of Caus. And we did a paper together on a long-term thermal overstressing of PCs, and you can access that, I think, on ResearchGate.
Mm-hmm.
It's available also on my website. But he wanted his problem was there were too many references for the editors. He had 135 or something. And they had, we could only use 35 or 15.
Well, the journals especially the printed journals. They're looking at, you're just going to fill 2 pages of this stuff. Come on, which one did you really use? Which one are you just citing because you want to get another citation?
Yeah, you mentioned blue sky, and you had to list all the places
that it's ever been listed as somebody figured out what the color
blue
is.
Sky is. And
what
was there? Anyway, you're right. Sometimes it's proving, going back to how the wheel was invented.
Well, there's something about journals and impact ratings. You want to be published in a journal that has a high impact rating, and that means lots of people provide citations from those articles, from their journal. And so feeding that system, I see lots of academics do this. They write a paper which is just a summary of their last 10 papers, and they write 10 papers that are just summaries of their last 11 papers and their last 12 papers.
Right.
And they pump up their own citations in the journals they want to be in and stuff. And I just, come on, this is just a game.
Yeah, it's kind of like, publish your peroration. You have to just keep publishing something. And that's,
that's the dark side, or it's part of the process for whatever reason. It's got a good intention. As a practitioner, though, right?
As a practitioner, in my time in the industry, I didn't see, a lot of people going to the journal reliability or whatever the IEEE reliability society's academic, their published notes. I rarely ever saw anybody looking at those, or they didn't have a lot of practical application. It kind of, I look at Cal's and they do great work with lithium-ion batteries, and some of the ongoing issues with the that and solar energy and wind energy issues, IGBT, insulated gate bipolar transistors, power systems, things like that. But they really don't. They have to focus on intrinsic issues, not the special assignable causes that, as I believe, are a lot of the reasons, the majority reason why products fail in the field.
Yeah. Well,
So,
you've seen it in conferences too, is where somebody's going to say, "Oh, we need a fifth column on our
yeah,
expanded FMEA,"
right.
or we need another logic style gate for the block diagrams that allows you to do this
Yeah,
exotic corner case that's completely fictional. And I'm
yeah,
like, seriously, you got nothing better to do?
yeah.
But
Well, again, we can't publish. Companies won't publish the real reliability data unless they're forced to by court order. So,
yeah,
we're just gonna have to. We
not
always have to
everybody.
live with that.
There's a IBM journal that's actually got great stuff in it. It's mostly about the innovations and discoveries and patent worthy type
Right,
stuff that's
right.
going to be public domain anyway. So they write the story behind it. That I find fascinating reading.
Yeah, I do too.
But it's the idea is the basic idea of these technical papers, it goes back centuries, is a way to share knowledge and bits and pieces of information so that you reading through this stuff and working your way through the citations and how this came about and where do you apply it.
Right.
For me, it helps me solve problems. Like, I didn't really know what a Wiener diffusion process was until I ran into a problem where the regression analysis was not going to be a straight line and with any of the distributions I could figure out. So this was a technique to create a model, a regression model for it. And that
Right.
became the basis for the first paper. Now, through that research process, I ran into my co-author who was a professor teaching, reliability and accelerated testing and this stuff. And so we got it published. He did the heavy lifting in the math side, and I had the data and understood the mechanisms.
Mm-hmm.
But the idea is that I use technical papers if I have a specific question or problem.
Right. Right.
What do we? Somebody has already looked at this. I'm
Right.
quite sure, right? It's a good thing I'm not trying to get a PhD because if I had to come up with an original thing, I don't know.
Yeah, like you see some intermetallic problem with your solder or something like that, and you go research it.
Yep.
You go look, and there's probably a paper about it.
Probably
and
a
somebody
paper.
else's.
The hard
somebody's
part is
done a
thinking
study.
of the keywords to search for. What if you knew the name of the phenomena, then you're halfway there. You could find those papers.
Yeah, right.
And then the other way I've used technical papers over the years is, oh, that looks interesting. I don't know anything about that, or how would I ever apply that? Or, I've never heard of that. And I would skim through or read those papers and pick up bits and pieces that wouldn't apply to help me today, but it sure broadened my field of awareness, I guess is the right word. I was aware of so many different failure mechanisms that
Right.
over the years I read about and how to do this and what's this about, how does
Right.
this occur, how does it show itself, that when I actually did ever see one of those things, I go, oh, I think I know what that is. Let me,
Yeah, and that's how we make more reliable products, by knowing those mechanisms like tin whiskers and things that were in the past
Yep.
and then suddenly reappear because of a major change in the solder formulations.
Well, that's one piece of it is there's just this perennial, we forget what we've already mastered. It hasn't been a problem in the last couple of years. So
Yeah.
it loses awareness and then
Right.
it comes back again. I don't know how many times I've run into people saying, oh, we're going to use bare silver on the board because it's got great electrical properties. Okay.
You know anything about corrosion in silver and
Yeah,
sulfur?
you know how silver likes to move? We call it the mobile ion for a reason, because it will build those beautiful little tree structures at a drop of a hat.
And wasn't there a problem with in high sulfur pollution areas? I thought something was silver. It was silver, and that there's some corrosive atmosphere or
Yeah.
something like that.
Well,
But yeah,
it doesn't matter what you use, something's going to
yeah,
take it apart somewhere.
exactly. Eventually,
Yeah.
but most of the time it's going to be technologically obsolete before that
Yeah.
happens.
Well, we'll refer to yet another one of your papers or
Yeah,
technical
well,
things there.
technical. Anyway,
Well, make sure you put all the links in here so that we can catch all these things.
okay.
You know, that kind of thing. But the idea is it was just kind of hit me as I'm going through all this coincidence. I'm getting this email of a new citation, and I'm going through old papers and going, oh, my wife wanted me to clean house a bit and get rid of, are you ever going to use these? And I'm like, well, no. So I'm paging through all these papers, and I'm like, oh, that's a cool paper. I really like that paper. I got to keep that one. And so instead of 4 feet, I have a foot now. So I called 3/4 of it. So hopefully that's a win.
Yeah, I hope you can cull it down.
Well, the other trick now is that I'll either scan them and put them, make PDFs out of them, or
Yeah.
I have library access, so I'll just download them, the ones that I want to keep, and put them in a place where I can find them again, that kind of thing. But the basic idea, the whole concept is one, you can learn from the history of what's been written. Two, yeah, it's not a perfect system, but it's sure better than not having all that previous knowledge. And three is a way to learn other things that catches your eye, might be interesting, or might scratch an itch for curiosity, or just
Right.
to professional reading. And four, it's a great way for you to share what you know, and, pay it forward,
Right.
basically.
That's why I write the book, is to help the next generation of people in reliability.
And
Have
the
at least
$2.18 you get per book.
I think less than that,
Oh, okay.
but yeah, I certainly didn't write it to get rich, and it certainly hasn't done that for me. But it has. You brought some citations, and I think it moved the. Hopefully, it'll be there. I don't know how long it'll be before it'll be technologically obsolete, but
Yeah.
hopefully, stress will always be a very useful tool in finding problems with reliability.
Yeah. Now, and so that's part of the process. So anyway, that was the thought for today. Is that, and
Yeah.
if you've
And Google
got
Scholar also,
Google Scholar
I
is
just
great.
mentioned Google Scholar has tons of papers, great research capabilities, and you'll find a lot of these papers that are behind a paywall or something are actually somebody in some country has done what you talk about, scan them and made them into a PDF and put
Well, a
them.
lot of authors like you and me on ResearchGate, if
Yeah.
we have access, if we can post our own papers.
Yeah.
So there's lots of ways to do it. But a lot of companies have library access in one form or another, or your
Right.
old alumni access to your library.
Right.
There's lots of ways to get at this
There are
stuff.
lots of ways to get to the stuff, yeah,
Yeah.
without paying.
But lots of stuff. So anyway, if you've been listening to this, and if you got, take one way or the other on the technical papers and how they're working with you for professional development or problem solving, let us know. Head over to ascendoreliability.com/go/SOR, and you can find a couple of ways to get in touch with us. The Kirk and I and the other hosts of the show are available through LinkedIn and our About pages. And I guess, Kirk, we're not looking for deep technical questions about some obscure technical paper.
No.
But if you got one of those that might be interesting, we might have to look it up and see if we can help you. But let us know one way or the other. So
That's right. Thanks for listening, all, and please send us in your questions. We love them.
yeah, sure do. Thanks, Kirk. Talk to you later.
Okay. Thank you, Fred.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.